Assalamu alaikum, my dear students of Pharmaceutical Organic Chemistry II. Today, inshallah, we are going to handle a new topic, which is about qualitative determination of amines. And we are going to proceed today with a new test, which is nitrization test, or we can call it as nitrous acid test. This nitrous acid test, it is very important in determination of the type of amine, as it can differentiate between aliphatic and aromatic amine. In addition to, it can differentiate between the primary, secondary, and tertiary amines. Of course, the nitrization test will include another chemical reaction, which we call it azo-coupling. To simplify, azo-coupling, it is any nitrogen bridge between two benzene rings, and the formed compound, we will call it azo compound. Okay, now we are going to proceed with this chemical experiment. We will start by drawing the chemical structure of the samples we have today. Tyrosine, as we know from the previous lab, it is one of the amino acids. So the structure will be like this. Which is linked to a benzene ring and linked to hydroxyl group. For the para-aminobenzoic acid, the structure, it contains carboxyl group linked to benzene ring, which is linked to amino group. For the paracetamol, once again, it is benzene ring linked to hydroxyl group and ethyl group, in addition to the amino group as a bridge between them. For the diethylamine, its symbol, same here. And for the triethylamine, it's similar to diethylamine, but in addition to one ethyl group. Okay. For the reagent we are going to use today, we have to use sodium nitrite, which is NaNO2, and hydrochloric acid, in addition to the alpha naphthol. The structure of alpha naphthol is as following. And beta naphthol, which is similar to alpha naphthol, but only changed position between them. So here and here the beta position. For the instruments and the chemicals we need to proceed this experiment, we already will explain it in the next step, which is the identification of instruments and chemicals needed. Now we are going to proceed with the procedures for today's experiment. We will have two test tubes. We will call them test tube 1 and test tube 2. For test tube 1, we will take 0.25 gram of the unknown amino compound, and in case of it is liquid, we will take 0.5 ml. So 0.25 or 0.5 ml in case of liquid samples. And we will place them in test tube number 1. Then we will add 2 ml of 1 molar HCl solution. Then we have to place them in ice bath with a temperature between 5 to 10 degrees Celsius. And we are going to explain why we have to do this step in the next page. Then we have to add 5 drops of 20% sodium nitrite solution. Okay, so this is for test tube 1. At this test tube, or inside this test tube, we have to notice if there is immediate gas evolved or not. So we have to observe if there is gas or not. Okay? If there is immediate gas evolved, so in that case, our sample contains primary aliphatic amine. Otherwise, it could contain other types of amines. Now we are going to proceed with test tube number 2. In test tube number 2, once again, we are going to take 0.25 gram, but this time we will do it as 2 separate tests. One time we will take 0.25 gram of alpha naphthol, and the next time we are going to take 0.25 gram of beta naphthol, and we will place them in test tube. So separately here we will have two test tubes, one of them containing alpha naphthol and the other containing beta naphthol. Then we are going to add dropwise of 1 molar sodium hydroxide solution with shaking till being soluble. Then we can place the test tube in an ice bath which have a temperature between 5 to 10 degrees Celsius. Then we are going to add few drops of test tube 1 to test tube 2, and we will observe if there is any color change. So in test tube number 2 we are going to observe any color change. Okay, this color change, it will tell us or give us an idea about the nature of the amine group we have, if it is primary or secondary, aliphatic or aromatic amino containing compounds. Now we are going to proceed with the chemical experiment, but before that I have to explain here for you what will happen. This is the general structure or the general formula of amines, and this is the nitrosation test or the nitrous acid formation. After the reaction between sodium nitrite and HCl, we will get HONO, which is nitrous acid. This is my target, which will later form nitrosium ion. This nitrosium ion is going to attack the amino containing compounds, and after a series of chemical reaction, it will form benzodiazonium ion. This benzodiazonium ion later, it will proceed with the coupling reaction with either alpha naphthol or beta naphthol. So we will have any of these chemical structure. Okay, as what we learned from Organic Chemistry 1, we know that hydroxyl group will have para-ortho directing effects. So wherever the coupling will occur, it will occur either on the para position or in the ortho position. And we will call these two positions as the major products. Yes, meta coupling will occur, but with minor amount. So the amount formed due to meta coupling, it would be very minor amount. While in the scenario of the beta naphthol, we found that the para position of the hydroxyl, it is already occupied. So the alternative position, it would be the ortho position. That's why in the coupling with the ortho position, we will have less amount of coupling or less products. So this will reflect the depth of color. From what I said, we expect that the coupling with alpha naphthol, it will be more deeper in color. Why? Because we have two positions available for coupling. So we will have para position coupling and ortho position coupling. While in case of beta naphthol, we will have the possibility only for the ortho position coupling, which will decrease the amount of the new azodiide or the azo compound formed. So we will have lighter color with the beta naphthol and darker color with the alpha naphthol. Okay, now we are going to proceed with the practical experiment, so please stay with me. Before we proceed in today's chemical experiment, we have to make sure that we have all the required chemicals and instruments required for this experiment. So we will start here by having paracetamol sample powder, para-aminobenzoic acid sample powder, tyrosine sample powder. Of course, all these powders are placed inside petri dishes with their spatulas. Then we have diethylamine sample solution and triethylamine sample solution. Now let's move to the reagent. This reagent is alpha naphthol, and this one is beta naphthol. Then we have sodium nitrite reagent. Then we have 1 molar of hydrochloric acid solution, 1 molar of sodium hydroxide solution, distilled water and distilled water dispenser, and an ice bath, in addition to plastic droppers, labels for the test tube rack, and test tubes with capacity between 10 to 25 milliliters. Now we are going to proceed. Okay, now we are going to proceed, but before that we have to make sure that we have all the personal protective equipment, including the gloves and the goggles. So let's start. To make our life easy, we will start by labeling the test tube. I will have two different sets of test tube. One of them I will label according to the name of the sample, while the second set of test tube I will call them according to the contained alpha or beta naphthol. So I will start here by writing the labels of our samples. So here we will start by tyrosine, then para-amino benzoic acid, then paracetamol, then diethylamine and triethylamine. Okay, so this is the first set. Second set, I will just call them, I will give them codes. I will say alpha. It means in this test tube, there would be a reaction between alpha and tyrosine. And in the second one, I will call it beta tyrosine. So it means in that test tube, I'm going to react alpha naphthol with tyrosine, and in that test tube, I'm going to react beta naphthol with tyrosine. And I will do the same for the rest of the samples. So alpha, paracetamol, and beta paracetamol. Okay, alpha para-amino benzoic acid and beta para-amino benzoic acid. Then what's still missing? Okay, so alpha diethylamine and beta diethylamine. Then I will react alpha with triethylamine and beta with triethylamine. Now I'm going to label the test tube. I will start by this set. This is tyrosine. Okay, I have to go the same sequence. So paracetamol, as you remember from the previous section, that we have to label the test tube on the apical part. So if we need to boil it or apply any heat, this paper will not be damaged. So this is diethylamine, and finally triethylamine. Okay, so this is the first set of test tube which will contain our samples. Now I'm going to the next set. I will start by alpha triethylamine and beta diethylamine. Oops, I just have to repeat it. It's okay. Okay, so beta triethylamine. It seems that the test tubes are wet. Okay. That's why it will be difficult to stick it. I will try to make it all around. And this one is beta. Okay. Now for the tyrosine, we'll start by alpha tyrosine and beta tyrosine. Then paracetamol, to be alpha, then beta, then para-aminobenzoic acid, the alpha and beta, and finally diethylamine, sorry, and beta. So now we are done with the two sets of test tube. As we said, these two sets of test tube, one of them will be holding the sample and the other one will be holding the alpha and beta naphthol. Now we are going to proceed with the next step. Okay, now we are going to proceed with preparing the content of test tube number 1. Simply, we will take 0.25 gram of the powder or 0.5 ml of the liquid sample solution, and we will place them inside the corresponding test tube. Then we will add 2 ml of 1 molar HCl solution. We will mix them well, place them inside the ice bath, and here is our thermometer to make sure that the temperature is not exceeding 10 degrees Celsius, between 5 to 10 degrees Celsius. Later on, I'm going to add 5 drops of sodium nitrite solution to each of these test tube, and we will wait till we prepare the second set of test tube. It's important to know that if the temperature increased more than 5 to 10 degrees Celsius, the formed nitrous acid will be evaporated. So we have to keep it in liquid form by putting it inside the ice bath. Okay, now let's proceed. Here is the test tube labeled as paracetamol. I'm going to take roughly 0.25 gram. Then I'm going to add to that 2 ml of HCl solution. So this is the first ml. Then the second ml. Gentle shaking to ensure that this non-dissolved particle will not go up. Okay, so now we are done with paracetamol. Now we are going to proceed with para-aminobenzoic acid. Once again, we will take 0.25 gram, place them inside. Then we are going to put 2 ml of HCl solution. The nice thing about para-aminobenzoic acid that it could react as an acid or base. So here it reacted as a base, so it's completely soluble after reaction with HCl. Okay, now we're going to proceed with tyrosine. 0.25 gram, the same. Of course, we have to consider the density. Then we are going to add once again 2 ml of HCl solution. We expect that HCl can solubilize the tyrosine, but it will take more time. Solubility here is not a matter for me, because the aim of addition of HCl not to make the sample soluble. No, it will be reacting with the sodium nitrite to produce nitrous acids. Okay, now I'm going to the diethylamine. These two samples have a very awful odor, and I hate them too much. Okay, so now we are done with the diethylamine. Now we are going to proceed with triethylamine. Once again, the most awful odor ever you can smell in your life. Okay, now we are going to take 1 ml of HCl and another ml, and now we are ready. Okay, now we are going to put all the test tubes inside the ice bath, but we have to make sure about the temperature. Yes, it is below 10, so I will take the test tubes and I will place them inside the ice bath. If you remember, that's why I told you we have to put the label in the upper part, so even now they will not touch the solution. Now we are going to count down for 2 minutes or 3 minutes, then we are going to proceed. Okay, now we are going to proceed. I will add sodium nitrite to the test tube containing tyrosine. 5 drops, 1, 2, 3, 4, 5. And yes, I can observe that there is bubbling. Okay, I'm going just to show it to you and return test tube quickly. I'm not sure if you can see it or not. It's very clear. Okay, can you see the bubbling from the bottom of the test tube? So we have immediate bubbling occurs with the tyrosine. Now we are going to proceed with the second sample, which is para-aminobenzoic acid, and we will find out if there is bubbling or gas evolved. Of course, this gas evolved, it is nitrogen. Now here we are going to do that. 4 and 5. Okay. Yeah, there is only few bubbles there, but it is not as much as in case of tyrosine. Even tyrosine, till now I can't see bubbling. Okay. Okay, now we are going to proceed with the paracetamol. Again, we have to add 5 drops. 1, 2, 3, 4, and 5. It's too difficult to work inside, but I will do my best. Yeah, once again, there is only few bubbles, but not as much as in tyrosine. So this is in paracetamol, but I cannot say that the amount of bubbles in para-aminobenzoic acid and in paracetamol comparable with the tyrosine. With tyrosine, there was a huge amount of bubbles there. Okay, now we are going to proceed with the diethylamine. There it is. Yes, this is the diethylamine. Okay, so 1, 2, 3, 4, 5. Okay, there is no bubbles at all. Okay, I can't see any bubbles. No. Okay, so now for the triethylamine, the last one. 1, 2, 3, 4, 5. Okay, so now I added to the tyrosine, but again there is no bubbles. So we can conclude that the bubbling occurs with tyrosine with higher extent and occurs in para-aminobenzoic acid and paracetamol, but with very low extent, and not happened at all in triethylamine and in diethylamine. Now we're going to keep these test tubes inside the ice bath. I want to give you a more closer view. If you can see, only one test tube which is still bubbling till this point, which is the test tube named tyrosine. If you can see, there is still bubbling from that tyrosine test tube. Okay. Okay, now I'm going to prepare the content of test tube number 2. So here the test tube, which will contain the paracetamol later on, the alpha and the beta. So inside the alpha, I will place 0.25 gram of alpha naphthol and 0.25 gram of beta naphthol. I have to make sure which one is alpha, which one of beta, so I will not get confused after doing the experiment. So once again, for the alpha and beta, for the sample which will contain or the test tube which will contain para-aminobenzoic acid. So here is the alpha naphthol. I think I need more. Of course, we are roughly measuring the quantities because we are only aimed to identify our samples quantitatively, not qualitatively. Okay. Now, once again, for the tyrosine, alpha and beta. The same for diethylamine, alpha and beta. And finally, with the triethylamine, alpha and beta. Okay, now I'm done. So to each test tube of them, I'm going to add sodium hydroxide solution drop-wise, just to make sure that the quantities inside each test tube are dissolved. So I will start here one by one. The problem with the alpha naphthol that it presents in the form of big particles, so the dissolving of that is not easy task, but it's done. Here, once again, in for beta naphthol, we are going to dissolve that in the same technique. Okay, it's done. Both of you together, just to save time. Yeah, that dissolves. Now with the diethylamine with alpha and diethylamine with beta. Okay. Okay, next and finally with the triethylamine. Okay, so we are done with that step. Now we are going to put all these test tube inside the water bath, the iced water bath, and it will be a big party here right now. Okay. And now we have just to wait for 2 to 3 minutes to make sure that the temperature inside all the test tubes are between 5 to 10 degrees Celsius. Okay, after 2 minutes, I placed all the test tubes that contains alpha and beta naphthol in the same arrangement we are done in the first time. Now I'm going to add few drops from the test tube that contain the amino containing compound, which is already reacted with sodium nitrite, to the test tube, to the corresponding test tube here. So I will start by paracetamol. This is the paracetamol. I'm going to add just a few drops to the alpha and to the beta. And I'm going to observe. Now you can see the color formed, the yellowish color formed in both test tube, yellowish to orange. It's actually, I think it's more to orange, it's more deeper in color. Yeah. Now you can see it, it's more clear. And we can say that the depth of the color in the alpha tube, it's more than the beta tube. Okay, now we are going to proceed with the next sample, which is para-aminobenzoic acid. So I'm going to add that to these two test tubes. And I'm going to observe the color change. Once again, you can see the color in both of them, and you can see that the color in the alpha tube, you can see the color in the alpha tube, it's right here, and this is the beta tube. You can see the color in the alpha tube, it's more deeper than the color in the beta tube. Now I'm going to proceed more. Okay, this is we are done with the paracetamol and para-aminobenzoic acid. Now we are going, we are done with the paracetamol, with the para-aminobenzoic acid. Now we are going to proceed with the tyrosine. Where is tyrosine? Yeah, this is the tyrosine. Okay, yeah, these are the two tubes of tyrosine. Even now I can hear the effervescence once again. You can see the depths of the color in the alpha tube more than the beta tube, and there was an effervescence in the beginning, so the same occurred with the tyrosine. Now we are going to proceed with diethylamine and triethylamine. I think the camera is getting everything fine. So this is diethylamine and this is diethylamine, so we are on the right track. You can see that even here there is difference in the depth of the color between both of them. Can add here more. Okay, now we are go to the last sample, which is triethylamine, and these are the two test tubes of triethylamine. Okay, and we are going to observe. Okay, we can see that in diethylamine and triethylamine, yes, the same scenario between alpha and beta, but the color is not very characteristic. The colors are very characteristic for these three amines which contain benzene ring. But here we have the same scenario, which is the difference in the depth of the color between alpha and beta in this test tube. Now we are done with the practical part of today's experiments, and we are going to proceed to understand what the meaning of the result we got. Okay, here's the board where we wrote all the results we got today. And test tube number 1 represents the reaction between the samples, the amino containing compound, we have it today, with the sodium nitrite in presence of HCl solution. We found that only tyrosine produced sufficient amount of gas, while the rest of them there was no gas evolved, or very little amount of gas, as in case of para-aminobenzoic acid and paracetamol. While in test tube number 2, here we reacted the content of test tube number 1 with the alpha or beta naphthol in test tube number 2. And we noticed that in all test tubes number 2, the depth of the color in the alpha naphthol test tube was more deeper than the depth of the color in test tube number 2, which contains the beta naphthol. So now I'm going to transfer all these data to the table in page number 2 in the worksheet, then I will back to you. Okay, welcome back. Now I transferred all the results we got in today's experiments inside this table, and now we are going to interpret and understand what is the meaning of the color changes and the gas evolved. Okay. For the tyrosine, we found that this is the only sample that evolved a gas. Okay, what's so characteristic in tyrosine and not present in the rest of the samples today? Let's go to the structure of tyrosine and try to get or to figure it out. In tyrosine, it is the only aliphatic or primary aliphatic amine. Okay, what about para? It is aromatic. What about paracetamol? It's mixed aliphatic and aromatic. What about the diethylamine? It's aliphatic but secondary aliphatic amine. What about the triethylamine? It is tertiary aliphatic amine. So the only primary aliphatic amine is tyrosine. So we will get this observation, which is gas evolved at deep orange color, in case of our sample is primary aliphatic amine. What about para-aminobenzoic acid? What is so characteristic about para-aminobenzoic acid? Let's find out. In para-aminobenzoic acid, it is aromatic amine. Is it primary or secondary? It is primary aromatic amine. So whenever we will have primary aromatic amine, we will get reddish color, in addition to fewer amounts of gas will be evolved. Okay, what about paracetamol? If you look to the paracetamol, you will find it linked to two-sided chain. So it's for sure secondary aliphatic or aromatic amine. So secondary aromatic amine, they will produce orange color, in addition to tiny amount of gas to be evolved. What about diethylamine? It's aliphatic amine, secondary aliphatic amine. So for the secondary aliphatic amine, it will not evolve gas and it will give us this color observation. Okay, for the triethylamine, what's so characteristic about it? It's the tertiary amine, aliphatic amine. So when we have tertiary aliphatic amine, we will get this result, which is no gas evolved and no color change. So this is the way we use the nitrization test to differentiate between different types of amine, either aliphatic and aromatic, or primary or secondary or tertiary. So by these findings, we already achieved the target of today's lab, and hope you enjoyed it. Inshallah, I'm going to see you in the next session. Assalamu alaikum.